Hey everybody, this is Ed. Today I'm going to go over LeetCode problem 395, finding the longest substring with at least k repeating characters. So the instructions are as follows. Find the length of the longest substring t of a given string that consists of lowercase letters only, such that every character in t appears no less than k times. Okay, let's look at this example. Alright, so our string is AAABB and k equals 3. So we need to find a string within this string that consists of letters that appear at least 3 times. Now the answer is 3 because there is only one such substring, AAA, that satisfies this requirement right here, because lowercase a appears at least 3 times. We can't have B be part of our string because there are only 2 B's, which is less than, the K for this one. Okay, so I think this is this problem is a good example to demonstrate divide and conquer. If you guys don't know divide and conquer, it uses a recursive approach to break a problem into 2 parts, and it keeps breaking the problem until it arrives at the solution. So since we're talking about strings here, strings and substrings, you might imagine breaking the problem would involve creating 2 smaller substrings from a string. For example, AAABB could be broken down into AAA and BB. Alright, to make this problem a little more relevant, we're going to use an Infinity Wars reference from the latest movie. So a little known detail about this movie is that the Avengers and Tony Stark was a mastermind of the Avengers plot to bring down Thanos. So he created this time-traveling machine that would bring the Avengers at different points in time to collect the Infinity Stones to defeat Thanos. But what they didn't tell you in the movie is that they used divide and conquer to defeat Thanos. So we're going to abbreviate that as DNC. And we are going to use the same example that they showed in example 1. So that string was AAABB. And the requirement is k equals 3. So we need to find a substring with lowercase letters that appear at least 3 times. So keeping with the Avengers analogy, so each different lowercase letter is an infinity stone. And the Avengers need to collect at least k infinity stones from a certain period in time to defeat Thanos. And of course, they want to collect as many stones as possible in order to maximize their chances of defeating Thanos, okay? So they have their time machine. So imagine this arrow represents time, with the left side going to the past and the right side going to the future. This is going to be 0. And these hashes represent different points in time. So where should they start searching in order to have a good chance of finding the correct subsequence of infinity stones? Well, if we count all the infinity stones in our search space, we get this. A is 3, B is 2. Now, a good place to split our, to find the right time to search to the left and right of would be to find the infinity stone that will not belong in our collection, okay? So which one would not belong? A? No, because A is greater than or equal to K, right? How about B? No. So B, the B infinity stone, I'm not sure what infinity stone that would be like the, I don't know, the bowling ball infinity stone, if there was a thing. That would not belong in our collection, right? So if we reach a B, if we see a B, this is a good place to split our string. We do not want to include this one, the letter that has a B, okay? So let's say the infinity, the Avengers have this power to see into time, right? And they are able to spot the infinity stone that they don't want right here. So they're going to say, okay, we don't want this. That means the sequence that we do want must be to the left of this point in time or the right of this point in time, right? So in this case would be 0, 1, 2, 3, and 4. Okay, so we're going to go from 0. So our new search space is from 0 to 3 and 4. And I'm going to copy this over here. So you see how we were able to divide this problem into two smaller problems, right? By using kind of like a trick to narrow down our search space. Okay. So now we have narrowed this down to problem 1 and problem 2. We are at this point in time. We have a start and end point in time. In this case, our start time for this string is 0, and our end time is 3. For the bottom case, our start time is 3. Actually, it's going to be 4, right? Because this is the second B in the sequence. It's this B. We decided this B did not belong. Okay, and this point in time is 5. All right, so we're going to do the same thing that we did in our original string, which is we're going to count how many instances of each infinity stone exist. So for this problem, we count it and we get A is 3. This is the only infinity stone that we found between time 0 and time 3. For problem 2, we only found one infinity stone, right? All right, so in this case, we do not find an infinity stone that appears less than k times. So what do we do? Well, that means this is a potential solution, right? So we're going to return it. We're going to return A as a potential Thanos killer. And B appears only once. And that means we can split this into a smaller subproblem that does not include B, right? Because it cannot be part of our sequence since it appears less than k times. But as you might notice, there are no other infinity stones before or after this point in time. So we're going to return an empty string, or 0, okay? Because there's no sequence of infinity stones. All right. So what happens when we return these? Well, if you remember recursion is kind of like, so this is our original string, right? So we divided this string into string 1 and string 2. These are our two smaller strings. So this is string 1, this is string 2. Okay, after we find a possible sequence of substrings, we're going to return this value to the parent, the function that called this function, okay? So it's going to return to the original caller. So string 1 returned 3 because our sequence of infinity stones is 3 long. String 2 returns 0. So if we go back to our problem, it's going to say find the length of the longest substring. So we're going to keep the bigger of the two strings. In this case, of course, it's 3. Right? And once you've kind of explored all the possible sequences of infinity stones, you're guaranteed to find a sequence if it exists, the longest sequence if it exists, because you've ruled out all the strings, all the infinity stones that do not belong, so you're left with the ones that do belong, right? In this case, the answer is 3. Okay, and remember that is this sequence right here, AAA. Okay, so the infinity stones have been gathered, and the Avengers can harness the power of the AAA infinity stones to destroy Thanos. So, bye-bye, Thanos. You are destroyed. Okay, thanks. Hope you learned something about Divide and Conquer, and hope this Avengers Infinity Wars reference humored you. And yeah, you can bring this up in an interview question and maybe get some laughs out of your interviewer. Okay, all right. See you next time. Bye.